In this experiment, you'll determine the approximate pH of several solutions by using acid-base indicators. Then you'll find the pH of some other solutions with a pH meter. Finally, we'll prepare a buffer system. To each of 5 small test tubes, add about 1 milliliter of 0.1 molar hydrochloric acid. To each tube, add a drop or two of one of the indicators listed in the following chart. Note the color of the solution you obtain in each case. By comparing the colors you observe with the information in the chart, estimate the pH of the solution to within a range of 1 pH unit. In making your estimate, note that the color of an indicator is most indicative of pH in the region where the indicator is changing color. Repeat the procedure with each of the following solutions: 0.1 molar sodium biphosphate, 0.1 molar acetic acid, and 0.1 molar zinc sulfate. Record the colors you observe and the pH range for each solution.
Using a 25 milliliter sample in a 150 milliliter beaker, measure and record the pH of a 0.1 molar solution of each of the following substances: sodium chloride, sodium carbonate, sodium acetate, and sodium bisulfate. Rinse the electrode probe in distilled water between measurements. After you have completed the measurement, add a drop or two of bromocresol green to the solution and record the color you obtain.
Now we'll make a buffer system using acetic acid and sodium acetate. Using a graduated cylinder, measure out 15 milliliters of the acid component of the buffer. Measure out 15 milliliters of the conjugate base and add it to the buffer. Measure the pH of the mixture and calculate pKa for the acid. Add 30 milliliters of DI water to the buffer mixture. Mix and pour half of the resulting solution into another 100 milliliter beaker. Measure the pH of the diluted buffer. Calculate pKa once again. Add 5 drops of 0.1 molar sodium hydroxide to the diluted buffer and measure the pH again. To the other half of the diluted buffer, add 5 drops of 0.1 molar hydrochloric acid and again measure the pH.
Make a buffer mixture containing 2 milliliters of the acid component and add 20 milliliters of the solution containing the conjugate base. Mix and measure the pH. Calculate a third value for the pKa. To that solution, add 3 milliliters of 0.1 molar NaOH. Measure the pH. Explain the results. Put 25 milliliters of distilled water into a 100 milliliter beaker. Measure the pH. Add 5 drops of 0.1 molar hydrochloric acid and measure the pH again. To that solution, add 10 drops of 0.1 molar NaOH. Mix and measure the pH.